we don't always want to compare objects in the same way every time. That's where the comparator is going to come in. So what do I mean by that? Well, I'm going to start by mentioning a nice term, natural order. It's sometimes used to refer to the ordering implied by the compare-to method of a particular class. So for example, in Java, if we look at how we decide how something's less than or greater than another, in this case a dog, we see that it only uses the size. So the natural ordering is simply the ordering of dogs based on size. So imagine we have 3 dogs. Here we have Doge, who's of size 5. We have Grigameth, size 200, and Clifford, size 9,000. They are ordered on the slide according to the natural order, where small is on the left and large is on the right. Now sometimes maybe you actually want to sort them in a different way. So maybe you want to sort them alphabetically because they're all in a class together, let's say a classroom, and you want to seat them in alphabetical order so that it seems fair, right? So in this case, if you sorted your 3 dogs by alphabetical order, we have Clifford, Doge, and Grigameth. Grigameth being last because Grigameth's name starts with a G. So how do we do that in Java? Well, let's think more abstractly first. Imagine that we were doing this in a language where we had explicit higher order functions where we pass the comparison function as a callback. In that case, if we wanted to print, again back to our print larger method earlier, if we wanted to do this with a different ordering, we would simply pass a different comparison function. So if you were passing callbacks directly, just pick a different callback, and then the issue becomes the person using print larger, they just have to pick the right compare. How do we do that with subtype polymorphism? That's going to be your question to ponder on this blue slide. So this print larger function, it takes 2 objects of the same type, it calls larger than, here we stringify whichever one's bigger, and the question is, how can you augment this code to support multiple orderings? So this one already automatically supports multiple orderings because you could simply pass a different compare function. So the question is, what could you do here? So I'll give you a couple bad ideas. One of them is we could have, instead of just compare to, we could have like another function called compare to 2, and another called compare to 3, and another called compare to 4. And then it's just up to the person who is using the class to look up and see what each one does, and you can have a bunch of them or something. You can imagine having maybe a string argument to the compare to method that says which compare, and then there's documentation someplace that tells you what string to pick to get different fields. You can imagine having maybe something more exotic where you have to pass or you have like an array of something, right? An array of functions. Is that a thing you can do in Java? No. Well, I guess in Java 8 you could. Anyway, but all those ideas are not what Java settled on, and the thing they settled on, ultimately, I find pretty clean. So the thing that Java uses is we will pass an object which will be of type comparator of t, and in this case it's going to be, we're going to make sure this is the type and this is the variable name. So we'll just ask that object to compare x's and y's, and as long as we have a comparator that actually knows how to handle these types, which we do here, see, then that'll give us our answer. So let's see how we do that in Java. I'll jump in, then we'll come back to this. So in Java, there is something known as a comparator. And since it's an object, the way we're going to use it is actually create a nested class inside of dog that implements a comparator. So in this case, we'll have public class name comparator implements comparator dog. Okay? So we're declaring to the world that name comparator is a type of object that knows how to compare dogs. Now here we see it says cannot resolve symbol comparator. And so to fix that, I'll say import Java util comparator. Okay? So this is something that we have to do for comparators. We did not have to for comparable. So comparable is just a little more important in the language. You don't have to import anything, but with comparators we do. So now that we've done that, we have public class name comparator implements comparator, and now we need to fill in the method that's required. What is that method? Well, I have it here on the slide. This interface requires that we implement int compare t01 t02. So I'm going to say public int compare t, okay? What did I say? T01 or 01 t02. I don't know why I'm saying 0. Now in this case, we actually get a complaint because the issue here is that this t is supposed to match whatever is up here. So we need to say, actually, dog. And maybe I'll call these things dog A and dog B instead. All right. Now the rule for compare is just like compare to. We want to return a positive number if A is bigger, a 0 if they're equal, and a negative if A is less than B. So to do that, we can simply defer to the string method, which has a compare to method. So in other words, we'll say, do whatever the string compare to would have done. So we'll say a.name.compare to b.name. Okay? So basically we're delegating all the work to the string instead of doing some kind of loop where we compare all the letters or whatever. That's already done for us. Okay? So now that we've created this name comparator class, I'm going to make a small observation. If you look here, you'll note that this does not use any of the instance variables of a dog. You could think of this as a name comparator is like the great sky dog, right? You don't actually need to instantiate a dog to get a name comparator, and so I'm going to make this class static. That doesn't really make that much of a difference, but it means I cannot use any of these instance variables, and it means it will also be easier to use the name comparator class. Okay, let's use it to make sure we see what's going on. So if we go to dog launcher, the way we would actually use this thing is we have to first create a comparator. So we can say dog.nameComparator, we'll call this inc, equals new dog.nameComparator. And that gives us an object that is capable of comparing dogs by name. We might then say something like, if inc.compare d1, d3 is greater than 0. That's shorthand for, I'll make a note here, if d1 comes later than d3 in the alphabet, then let's have d1 bark. Otherwise, let's have d3 bark. Okay? And so if we run this code, it should be whichever of these two dogs comes later in the alphabet. Hopefully you can see that Elise is the answer, because E comes after B. And indeed, first, this is Benjamin barking, and then lastly we have Elise here, who is barking. Okay? So this code certainly works. Now there's one little difference that I'm going to do here, just to reflect the way Java code is usually written. We don't often do new dog name comparator. So instead, what I'll do is I will go into the dog class, and I'm actually going to make this class private, okay, which of course will break dog launcher. And then I'm going to make a public method called, that's going to return a comparator of dogs. The name of the method is we'll call it getNameComparator, something like that. And then we'll simply return a new name comparator. Okay. Now, is this really any different? No. But it matches the kind of code that exists in existing Java libraries, and we might get a sense in a week or so of why this is useful, but I'm just doing this to keep in convention with what normally people do. So in this case, instead of having dog.nameComparator, nc equals new dog.nameComparator, we'll do dog.getNameComparator. So it's a function that generates name comparators and returns them. Now we look here, we actually have an issue, which is that getNameComparator cannot be referenced from a static context. And what's being complained about here is that I forgot to make this method static. Okay. Challenge for you. Try and figure out how to actually get a name comparator without putting the word static here, okay, if you want. Okay, now last thing we need to do is that dog.nameComparator is a private class. So we need to somehow get a container that can hold dog comparators. And it turns out you can actually do that simply with comparator of dog space nc. Now again, we get a complaint, cannot resolve Java a symbol comparator. And we could do something like java.util.comparator, though that's quite a mess. I mean, who wants to do that everywhere they use a comparator? So instead, I will use an import. And we'll talk about imports in more detail in the next lecture video. Okay. So finally, we have code that looks more or less like real Java code. The dog class has a name comparator class that is private. We have a method that returns a comparator. And then finally, to use it, we simply create a comparator, store it in this variable, and can use it. Okay. So all of that said, right? In Project 1B, you get a chance to actually play around with this a little bit. You're not using the official comparator interface, but you'll build something quite similar. Okay. So in contrast to other languages where you would handle this simply by passing a different function as an argument to a method that's supposed to do general work, now we're passing a comparator to a function. And that allows us to have general code. Okay? So if we summarize how things look in terms of in the inheritance hierarchy, we have a comparator interface that's built into Java. We have a name comparator, which we just built. That's a private class that implements this comparator interface, right? So if we look at our code in dog, this class implements the comparator dog interface. And we could also write a size comparator, though we will not do so here. Now notice that when it comes to inheritance, the dog class itself is not part of this tree. It's not that size comparator is a dog. It's not that dog is a size comparator, nothing like that. Okay? And so ultimately, what we end up with, just for your reference, is code that looks something like this, where we have a name comparator here, and we can invoke them. And this is a little different because I didn't have space to do the private method. One more time. I didn't have room to do the private class with public static method that returns a copy, and it's not a big deal. I mean, you shouldn't look at this and think like, okay, that's a lot better than what's on this slide. This is just convention, but hopefully it makes syntactic sense to you. Okay, so that's name comparator. So to summarize everything we just did and all of this video, interfaces ultimately in Java provide us with the ability to make callbacks. What's a callback? Well, sometimes when we write a function, like the one we did today, max, we need something. We need compared to, something to actually do the work. So it's kind of like if you have a friend who is, watching your dog. There's a lot of dog stuff happening here. And you give them your phone number and say, hey, please call me if the dog needs something, like food, and I'll tell you where it is. And so in that case, it's considered a callback, right? So some languages handle this by having explicit function passing. That's the way you do things. It's a very functional style. But in Java, we do it by wrapping the needed function inside of an interface, either comparable or or a comparator. And that lets you call, for example, let's say arrays.sort. And in that case, when you call arrays.sort, it will call your compare_to method every single time it needs to make a comparison. So imagine a sorting algorithm like selection sort we wrote. It will just keep calling compare_to every time it needs it, and that compare_to method tells you what to do. And so ultimately, Project 1B, you'll get a chance to play around with this a little bit, and I think you'll like it. Now, one thing we won't tease out in Project 1B is the difference between a comparable and a comparator. And so the only difference is that a comparable says, I want to compare myself to another object, and a comparator compares to other objects. So it's a subtle distinction. So they're related concepts, but I'd say they're mostly orthogonal. So if you implement comparable, you're comparing yourself to other objects. And then what a comparator does for you is it compares to other objects. And the only reason we did that is because, well, there's only room for one compare_to function. And so if I want multiple ways to compare, I have to ultimately, in Java at least, turn to the comparator idea. That's it, I think, for this video. So we'll see you next time.